Welcome to session 5 of microcontroller subject. So module 1. So we have seen 4 sessions. So microcontroller architecture of that, and register map, and after that so pin diagram, okay, RISC architecture and Van Neumann and Harvard architecture. So after seeing all those things, so during the pin diagram, so you have seen 8051 has 4 ports, okay, P0, P1, P2 and P3. Okay, there are 4 ports are there, each of 8 pins. So now how to today in this session we will know how to configure the pin number, particular pin number, either input or output. Okay, how to do the read and write, so that the configuration, so we will see today how to configure the IO pin of the microcontroller. Okay, so now that we can call as input output pin control. Okay, so now hardware structure, so what the hardware components of the IO pin structure. Okay, so we will see the only the pin, IO pin at the end of the IC, but inside that we have the hardware circuit, so which will control the pin numbers, means which will control the direction of the IO pin and how to handle the data of that. Okay, so this each pin of the IO ports, so which consists of the internal CPU bus. Okay, means the whatever the data lines, what we will call, okay, the internal data bus, it will be connected to the particular pin. Okay, so one pin connected to the one bit, like that. Okay, then it will have the delatch. Okay, delatch to store the value. Okay, so while writing also and while reading what we have written, so that also we can read that one, and whatever we are reading, that also we can store. So that is delatch. And we have in the hardware structure the two tri-state buffer. Okay, tri-state buffer in the sense, so what is a tri-state buffer basically? So based on it is like we call as the normal buffer only, but with that one control pin will be there. If it is the control pin is active, okay, so if it is active, then the data will transfer from one side to other side. Otherwise, if the control pin is disactive or inactive, then it will be a high impedance. Okay, it is that we call as a tri-state, so high impedance. So there are two tri-state buffers. Okay, and one the transistors. Okay, so transistor will be used, so that gate of that, it will be controlled, will be given to the control signal. Okay, so based on the value it will be controlled. So now the each IO pin, each pin will have the structure of this. Okay, that is two tri-state buffers, one D latch, and the data bus coming from the microcontroller, it will be connected to that, okay, particular bit, and one transistors. Okay, so this is uh, the structure what the each pin of the microcontroller will have. Okay, the same thing if you see, okay, there is D latch. Okay, D latch means it is the difference between flip flop and latch is, the flip flop is nothing but the repetitive or the synchronous clocks, it will be given to the latch. Okay, suppose latch in the sense, so there we will give the enable signal. Okay, so clock here it is showed, but we will use it as a enable signal, as a asynchronous. So whenever we want, we will give the pulse. Okay, like this. Okay, so whenever we will give the pulse, as it is active low during the neck gauge. Okay, during the neck gauge or falling gauge. Okay, whatever data is there, you can observe here, the pink line is neck gauge here. During that time data is high, so output becomes high. It will remain same until next falling edge. Okay, during this falling edge data is low, so output becomes low, so it will remain same one until it gets the next edge. So again it is at this point, the data is low, again it is low, no change in the output, so it will go on like this. Okay, so this is how the input will be latched onto the D latch. Okay, using D latch. So now this is component, and now, okay, this is port 1. Okay, so port 1 pin, the hardware we are looking here. Okay, so port 1 pin, so this is a, okay, this is actually from the outside the pin is connected, means the IC pin whole, this we can call as IC. So this is outside the pin. Okay, so now what it already told, the two tri-state buffers, this buffer TB1 and TB2 tri-state buffers, and this is M1 is a transistors, and this is load is a resistor here, and which is connected to VCC internally. Okay, so this is the IC part inside, and this is external. Okay, and here the latch is there. Okay, and this is a CPU line, what it is connecting internally from the bus. Okay, so this is the write control signal, and this is read pin. Okay, write to latch, this is control signal which coming from the microcontroller CPU, and this is read pin and read latch also. These are the control pins: write to latch, read pin, and read latch. Okay, so these are the control signals. Okay, and okay, same thing we can see here, that is read pin and read latch. Okay, and write to latch, these are the control signals, so what we'll use in the hardware circuits. Okay, so now, so this is basically the component, so hardware structure, what it is using for each pin. Okay, each pin of the microcontroller, this is with respect to the port 1. Okay, so now how it will read and how it will write to the value to the pin. Okay, so that we will see by taking the example. Okay, so here writing 1 to the output pin. Now writing 1 to the output pin, so which signal need to generate? So writing 1 means first this from the internal bus we need to write, we need to send 1. Okay, from this is a bus single line, what it will coming from the microcontroller, we need to send 1. Okay, so this is 1. Then after this we need to control the signals, so what we need to do is we need to given this write to latch, so write to latch should be 1. Okay, so write 1 to the pin internal bus and write to latch, so write to latch should be 1. So when it is 1, what will happen, the 1 will be stored on to the latch. Okay, so 1 will be stored on to the latch, so Q will be 1 and Q bar is complement of that, it will be 0. Okay, so if it is 0, the transistor will not active. Okay, if it is 0, the transistor will not work. So if it is will not work means it will be open here. Okay, if it is open, the whatever load is there, it is connected to the output. So load means it is connected to VCC, that is nothing but high, so output will become high. So there is one more reason, not only this, and this tri-state buffer during the write condition it will be inactive. Okay, so when it is inactive, so it will be high impedance. Okay, so 1 dash HZ, so this will be high impedance. Okay, as it is high impedance, again it is like open state, so whatever the value VCC, it will go to the 1. Okay, so like this. Okay, while writing, the write to latch it will be active, the data 1 will be stored here. Okay, and whatever we have written, and the same thing also we can read back, same thing also we can read back by activating the read latch, what we have written. Okay, that is optional, but whatever we have written 1. Okay, if you have written 1 means the output should become 1, so this will be inactive, and VCC is nothing but high signal, so that is 1 will be output at the P1 pin. Okay, so like this, by controlling the deactivating the read pin, this is enabled. Okay, by doing these two, and we are getting the output as 1. So this we call as writing 1 to the output pin P1 dot X. Okay, means P1 has 8 pins, so any one of the pins means all 8 pins or any one of the pin all have the same structure, the working is same. Okay, similarly if you go for writing 0. Okay, writing 0, so what we need to do is, okay, so what we need to do, we need to means the write from the bus we need to write 0. Okay, from the bus we need to write 0. If it is 0, Q will be 0 and Q naught will be complement will be 1. So if it is 1, and this will be active and it will be shorted here, shorted to ground. So if it is shorted to ground, and the 0 will be, if it is shorted to ground, so 0 will be at the output, and the same thing, this read pin is inactive while writing. Okay, so as it is inactive, the output is connected to ground here, and the output will be 0. Okay, so by writing 0 to the from the bus, activate write signal, deactivate read pin, and the output will be 0 here. So this we call as writing 0 to the output pin 1, port 1. Okay, so now this is regarding write 0 to the output pin. Okay, now how to read the high from the input pin. Okay, how to read high from the output pin. Sorry, input means now the pin will acting as an input here. Okay, so pin will acting as input. So here 1 is there. Okay, so in this case what we need to do is, initially before reading, initially we need write 1 to the port. Okay, write 1 to the port. You can see here move, they have written move p1 comma hash 0 ffh. H is a hexadecimal. If you are using any alphabetic, we need to put 0 before that, then it will consider as alphabet. Okay, so ff means all are high, so all are high we are writing to the port 1. Okay, so while reading what we need to do is, first we need to write 1. If you do the write 1, what will happen? So this will be 1 and this will be 0. If this is 0 and this is disconnected, or it will be open. Okay, so if it is open, it should be open, otherwise it is will be connected to ground here. So if it is open, so whatever the signal is coming from the outside, so it will go like this. Okay, to go like this means the read this particular buffer should be active now. Okay, earlier it was disactive, now disable, now it will be inactive. Okay, so sorry, it will be active now. So if it is active, so whatever signal is coming, if it is 1, so 1 is coming and it is going to the internal bus. Okay, it will be go to the internal bus. So initially write 1, that will make the this transistor off, then move a comma, then move a comma p1. A comma p1 means the p1 content will store down to the a. Okay, so what will happen? So this will, the data will come and it will go to the data bus. So from data bus whatever is there, it will stored into the a register. Okay, so like this it will read the high value to the, means the microcontroller will read. Okay, and okay, so this is how I will read. So this is how the data will come from the outside and microcontroller will read. Similarly, if you go for reading low, okay, so reading low also, so what we need to do, we need to make this transistor as off by making writing 1 to the this latch. Okay, later means if it is coming 0, so now if it is coming 0 means the same way, either it is 0 or 1, it will come here, activate this buffer and it will go on to the internal bus. Okay, at that time we will not activate this read latch because we need to read from the outside, not that what we have written. Okay, so this will be active only when whatever we have written, is it written or not, so that we can take as a confirmation by reading the latch. But while reading, so this will be inactive and whatever data from the outside we can read from the bus. Okay, so this is how the hardware structure for each pin it will work, and it will read from the external pin. Okay, so now as we know, port 1 and port 1 2 3 all are same. Okay, so port 1 2 3 all have the internal pull up. Okay, so internal pull up in the sense whatever this load is there, so that is nothing but a resistor. So VCC will be connected to the some resistor, so which will acting as load like RL. So whatever the voltage it will be connected here, so that will be supplied as output. So P1 P2 P3 all three ports are internal pull up, all have internal pull up resistor to VCC. Okay, so whereas if you come to the port 0, okay, so port 0 it has external, the port 0, only port 0 need a external pull up because it is not internally connected to the, so here it is not internally connected to the VCC. Okay, it is not connected here in the port 0. Because of that, it needs the external pull up, otherwise all working is same. So externally, the outside the IC, okay, externally it will be connected to the VCC. So either it can be 3.3 volts or 5 volts. So usually the microcontroller, the TTL volt, that is 5 volts, it will be connected. Okay, so this is how all these pins are, it will be act as input or output, and it will write and read the values. Okay, the difference is here externally pull up, all again the working is the same like port 1. Okay, so this is how in the port 0 all the pins, that is P0 to P7, it will be connected to the VCC. Okay, so VCC is, we can normally we say as the 5 volts. Okay, so 10k they have taken as a register load. Okay, so this is how it will be externally connected, and internally it is the same hardware and how the same working is there for this port also. Okay, and other pins, as I said, the P1, P2, P3 have internal pull-up registers. The only P0 don't have the internal pull-up, so we need to connect the external, so that we call as the P0 is open drain, so it will be openly kept. So we need to put the registers and connect it to the what, connected to the VCC. Okay, so all the ports okay, all the ports upon reset are configured as output, means in the during the reset. So as I told, we have seen the reset pin, so default, so once we press the reset button, whatever default settings it will be activated. So default all the ports are activated, means all the ports are configured as output. Okay, so once the reset is deactive, so based on our requirement through the programming, we can set either input or output. Okay, so this is the so this what we have seen in this session. So the 8051 has 4 ports. Okay, so each pin, the port 1, 2, 3 have the internal pull-ups, and each one we can configure as input or output, and how it is working, how it will write the values to the port, and how it will read from the port. Okay, so this all we have seen in this session. And the images are I got these images from the internet source. Okay, I greatly acknowledge them for using that the images.